stream, where knowledge reigns supreme. Calm and collected,
Fixerbot says.
Welcome. Stream starts in 5 minutes.
high expectations, gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow in this stream of knowledge. Together we'll grow.
Fixerbot says.
T-minus 4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow in this stream of knowledge. Together we'll grow. Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean.
Stream about to start. 1 minute left.
Gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow in this stream of knowledge. Together we'll grow.
Welcome in. So, today we're gonna continue on the path of offensive pen testing, and we're almost finished with the buffer overflow section. So we're gonna do this one, then it's Active Directory stuff, and lots of more fun in this path, really. So, reverse engineer a Windows executable, find a buffer overflow, and exploit it on a Linux machine. That sounds hard. But it can't be that hard, right? Because we'll see. Let's start the machine, and then, before we do it, we're gonna do some unboxing, right? So I got some mail yesterday here. So I guess tiniest first. Is this all the things I ordered, or what have we got? I think I need scissors actually. This seems like stable plastic. So, by the way, I can't even see that. Had to put up a preview. So, solar paste. Syringe flux for soldering SMD. So here's solar paste. So that's the thing to test later. It's just a few things. Well, this seems to have more things in there. Am I cheating? Is it cheating? So I don't really know what's in here. Oh, so in this bag there's a bag. Not the most fun post probably for other people, but I've been waiting for this. Oh, that's a lot of things. That's why it's. So here we have flux. So I've never had flux this in this form before at home. So it'll be nice. It'll be nice. There. And I think this is. If this is only the same, I am hoping for the solar tip cleaning thingy too. Hope. Because I think I ordered it at the same time. So I could kind of feel it was these things, right? Okay. So. So these seem to be like missing parts compared to these, right? So. And these came with this too, right? Well, we'll see. So, I guess I'll just put it all in one pile. We'll have to test this later, but not now. I still feel like I shouldn't jump around. I should like be kind of stationary right now. So, time to get started. I'm just thinking, where's my camera? We don't need to have that on. So let's just close it. There. We can close that one too. I should really uninstall that. Java update. Well, time to get started, right? So, just got a message from a friend there. I'll answer later. Brainpan 1. Also, the 1 makes me curious. Is there a 2? Let's start with checking this out. There's only a 1. And why is this mentioned? Well, Brainpan 1. Reverse engineer a Windows executable and find a buffer overflow and exploit it on a Linux machine. I'm kind of assuming that there's not much more information, right? We start to click the start machine button. Brainpan is perfect for recipe practice and has been highly recommended to complete before the exam. And I think they've removed this bit from the exam. Exploit a buffer overflow vulnerability by analyzing a Windows executable on a Linux machine. You will get stuck on this machine. If you get stuck, don't give up or look at write-ups. Just try harder. Yeah, so we can do that. All credit goes to Super Ecologyman. This machine used to machine user is explosive permission on create. I'm sorry. Oh, okay. So this machine actually is on vulnerable too. Okay. So, so here there might be more than one then. Yeah. So we don't need to get it started on a hypervisor, as it said here. We can just do track and it started. And I guess this is why we only have these, because it's not really a track me box, so they couldn't put flags in there. So if we click this dude, series. Yeah, there's a 2 and 3 too. So, interesting. And they're from 2013. So these are real old ones. I'm sorry, I still got a bit of a cold. Well, I guess we just get the IP, right? It's not like we have anything else. Kali is running. Let's start the nmap. Well, then I'll start. I'm like, what? I'm too tired to remember a command. I just woke up. This is too stupid. Whatever. All ports. Yeah. We want to do all ports. Nmap. I can't spell nmap. P. So I've been up for 1.5 hours at least. It still looks like I just woke up. So let's make some notes here. By the way, we should. I will make a new folder first. Brainpan 1. Now we know why there's a 1. And we should put done on this one. There. Though, while I'm at it, why not fix? I have a bit of SMB here. That it didn't. I forgot to put it in the other notes. So the reason we have gatekeeper here and here is that I started from scratch after not doing it for 3 months. I was doing lots of other stuff. Oh, I can see lots of X20s here on the end. It's finished. So let's just hop this over because there was missing information here. Oh. So this broke. That broke it. Let's do this instead. There. So it's assuming HTML. That's why. So just the download of the files. I think there's something else missing too, but whatever, it's okay. I can fix it later if we need to. They like the name Brain, it seems. No, we don't want a folder. Can we undo that? No. I'll let you delete. And then we do new note instead. 0 info. New note 1 nmap. And we're gonna put the nmap output here. Yeah, we're gonna read it, of course. Oh my god. I got up in the history. I was like, what's this? Never run nmap. Yeah, so we can see that my increased history here. Now we're up at 2,406 since we changed the history length from 2,000. That's very nice. Very nice. I hated when stuff disappears out of history and you were like, was it too long ago since I did this? There. So we have 9999. Welcome to Brainpan. Enter the password. And we have a simple HTTP server. Python. Okay. Site doesn't have a title. Pipes and spaces. Welcome to Brainpan. Okay, so 2 ports. 2 ports, that's all. So let's actually And it also says welcome to Brainpan. Let's look at the parts. Let's netcat. Check them out. Python 2.7. Let's also remember to actually put the information we got into info, because that's the purpose of it. And I've kind of like not followed my own way of doing things lately and just skipped through putting it there. Let's be organized, right? So we have 9999 and 10,000. So let's see. Oh, I forgot to put the IP in there. So I want the IP here on the top, because now we want the IP. So nice to be able to see that. Of course it's QWERTY. Okay. So let's write 10,000. Oh yeah, it's a web page. Let's connect to this one with a browser. And now let's open Burp too. It's so slow, so we'll need some time. Oh, it's actually updated. So I have not right. We downloaded that. So there. So let's burp on. It's almost done. Okay. Let's just do the. Did I copy now? Because I kind of copied other stuff. I'm just gonna grab this information from netcat and just put it in the notes, right? So we have both outputs and web. So the first thing we saw was almost looking like an image, right? Looks like an image. Am I supposed to recognize this? Infographic final. I guess we can open link in new tab. 2012-03. So this image is just from the site. We know this is a simple Python. So it's not like, though it is a, I'm guessing Python 2.7 was new in 2013, right? So that's not supposed to be like any vulnerability looking in there. And it's not a real web page. So can we zoom? We can. So I can assume more than just an image. So there must be something interesting in this. Our application really that unsafe. Top 5 application vulnerabilities. Let's talk about ESO, XSS. I didn't expect to find a web page as the first thing on this one, as it's buffer overflow. But it's nice not to have the same thing all the time. XSS. Reversal. Yeah, right. Direct reversal. Yeah. So we're getting a file from the hard drive, and it's a Python. So we could probably just change the path to anything, right? Can we even get directory listings? Which one was it that we could get directory listings in? So let's yeah, so I prefer keeping stuff not that long in there. So do I have 2 Firefoxes running? Okay, that's odd. So so in burp, I'm trying to add all sites that I don't want in there. Exclude host. And we get a long list here, and we want this to be a star. And I think it's better to do those. Or no? Why is one? Maybe it's this that works better. So I know the list will be infinite, but not really needing to have that one, but still. So let's send these to repeater. And that's not really what I meant to do, is it? Yeah, I think we want to actually intercept it. The intercept is so messy. If anyone has tips on a better way of doing it. So what I want to do is to edit this. So we just F5 this. And we should of course turn intercept on first. And then we F5 it, we get this, and I could just, I don't know, let's just try this. Do intercept request this response. Maybe I can just go to anything. Oh gosh, yeah, of course. One thing at a time. So I did do the do intercept, and then I have to forward it. And this is the response, and this is just stupid, but I could just, well, will this work, you know? And it also said XSS in the, like, hint there, I guess. It was so long since I did anything like this. So, if we now, I guess, forward that. And it is this one. No. Let's just forward. Whatever, so and then we look at the source for this. Because I want to see this, right? I don't know if you can do this, you know. I'm just testing stuff. Where can I like see the I want to see the code here. Yeah, so this is what it says. And then we got a broken image back. Yeah. So, but when I took view source, I got that. So that's why. But here we can see what it sent. So we could just try putting anything there, of course. Why put image, right? I don't know what I'm doing. I should try XSS as is kind of suggested, right? It just feels like it's a Python web server. Oh gosh, what happened? I was going to Google this. Why did I hop into burp? Because I have intercept on. So something just popped up from me not doing anything. Oh ho ho. Python 2.7 HTTP. I don't know if I want to do XSS. But that at least put us in the right theme, right? We could just try stuff. Basic stuff. Basic XSS. But it will work, of course, right? Maybe I shouldn't have done this today anyway. Well, I thought I'd wake up without a headache. I didn't. No, but I want to do this. So, worst case, we see if we can get a tiny hint somewhere because I want to continue web. Yeah, I was looking for something yesterday. So, of course, this an error. But I'm looking for something nicer. It's Python too, right? Could we put code in there? Nah, I want to Google this. So, Python 2.7 HTTP export vulnerabilities. Yeah, so I'm kind of thinking also that maybe, yeah, but this is 2012, right? So I don't want to be nearer than 2013, as that's when the box is from. And Russell Surfer's code execution vulnerability. Did it say? Yeah, so I don't think this has anything to do with HTTP, does it? Read the end of the page. But show me the darn hits then. Okay, so it's not in readable text. Oh, there. Yeah, so it says it's listing. I thought at first this search was bad. It didn't hop. Of course it's HTTP in the text, but it doesn't have anything to do with HTTP. So let's look up for something else. I'm going back in there just to grab the simple HTTP server one here. So if we search for that, we'll have a better chance. Or we could do it on HTTP server. List any file in folder. Issue. Could we just try and type a path here? I don't know how the HTTP server works. That would be kind of buggy, right? Yeah, that's what it says here. But we had to replace dot with this. That's so odd. Path? What was path? So, go back here. Windows executable, find a buffer overflow and exploit it on a Linux machine. So first of all, we need to find that Windows executable, right? And we can see where we're supposed to enter the buffer overflow. And we didn't even try and just overflow the buffer. So let's go back to the netcat window. This one. Well, let's do this in the new tab. So, if we put a lot of characters in here, what could be enough? Yeah, so if we were to put too many, I'll take the opportunity to drink while I press the 1 key. We could just do a fuss for this and see when it crashes. That didn't happen. And we got a connection refused. Will it restart itself? I'm kinda assuming. So if it doesn't restart, we'll have to restart the box to get it up again, which doesn't matter much, but it's annoying. So this doesn't make this, we'd get access denied, and this, it just dies and crashes. I should have taken tinier steps then. So at least we know it crashes there. But we don't know what's running in the background, and the previous ones we've been able to, it's been like SMB open and we could have find a file and stuff. So now we only have the web thingy, and web is not my best. But let's try just let's imagine it can work doing this, because now we're even doing source. Well, that's good. Let's just do this like this. It's a Python, right? And let's do ATC password, and we want this in text, right? And it says file not found. Error response, file not found. Yes, I think this probably works with the Python ones. And as we're if you were to send this thing, which is the same, yeah, where did I go there? So it removed all the dots, right? So if we go to this web page that I found, which was kind of odd, replace all with, let's just try it. Very odd thing, very odd. If this were to work, I'm fainting. It said in the text, right? Let's do one more. Yeah, but they were not removed. But we're not going to see, because I don't think this is Windows. On Windows, yeah, directory traversal on Windows. Yeah. So this must be Windows only. On Windows. Yeah, so let's see what else we can find. Because C: is very Windows. But we can try and find a file there. I would like to report path traversal. Date. We have to check the date. Oh, 2018. So I wouldn't want to use something called so what was really sent here? If it is the browser cleaning it up for it. Yeah, it is. So My god, I can't even find the right key on the keyboard. File not found. Error response for 4. Nothing matches the given URI. TMP. Oh. They actually do this. Yeah, we're not getting that either, but we're not having as many ups as they do either, so let's crazy it. Get. Yeah. Accept. So we don't have text and stuff. How much will that work? We have image. So we don't want an image. So why would it even say this? No, let's replace it with this. I'm curious why it selected this. The browser, that is. Why did the browser do that? Didn't think that would change anything, but I'm curious. Oh. This would be cool. Yeah, never intended to be secure in any way. This case is, however, also a clear bug. Should not behave this way, even in dev use. So this is 2018. The bug must be later. So this is a good thing to know, you know, but it's very old. Very, very old. Even our stuff is older though. Yeah, I'm taking it very easy. I still feel the headache, and it's annoying. And it's tempting to try and see if it was an energy drink, if it was caffeine, and I'm not used to it, you know, which would be so very funny. But then it would fix it. But I don't want to get headache if I don't eat energy drinks, so I'm not gonna do that. Date 2014. This is newer than the one. So this is newer than the box. I should just skip everything that's newer than the box, right? We can dig like this for a bit, but I don't want to do it forever because I feel I need to get better at web stuff. Let's just skip it as it's newer than the box. So newer than the box, not allowed, right? I read 2011, which is 2 years older, which is a reasonable thing that people do. 272. And what did we have? Let's just hop to the notes. Oh, I didn't keep it up. And map. We have 273. So it's also 0.6, right? So we should really be more specific. We could also do like POC instead of exploit. This sorry can be abused to the redirect to almost arbitrary URL. This is what we want. Open redirection. The URL post us was suggest 2 slashes. Reported vulnerability. Open a web browser, go to %2f dot. Echo get mode permanently. So it's 2% it is 2f the slash lots sheet. Show me the darn ASCII table, thank you. So 2f. Yeah, it is. Where am I now? Close. Didn't I read that thoroughly enough, apparently? They're using the full thing in here again. I don't think that would help, right? So we don't want to put a web address here. It's interesting to read these things though. But I'm not feeling we have any progress. But I guess I'm learning things. But it's old ancient things, so. But it's interesting still. So they didn't test. This vulnerability was reported to Finland Security Response Team 2017. Oh, so this is too new too. I should check the dates first. Yeah, and then we have Brainpan, which is what we're doing. Especially this kind of old thing, you know. What's this about? Just starting it. Yeah. Whatever. Maybe it's time. So I don't want to bore people with mega old bugs just because. And they did it 2019 when it was still in the OSCP, I assume. And we're just gonna check a tiny line here. They did the Volhub one. By the way, let's see if it started the... this again. Yeah, it did. So there was a timeout and it restarted this. So we don't have to restart the box. It's working again. Kinda thought so. There was a long delay only before it started again. That's nice. So let's do this. I don't want to get too much. I just want a tiny hint. So we found those. Oh. So how would I know this? This is not good. Too much information. I couldn't know that. I'll have to see how they found. I would have preferred the CV number, or something, so I could get a hint in the right direction, but not the full answer. But we were on the right path, that we need to get it that way. So it wasn't. It's just that we need to find the right way to find it. Another Brainpan. Buffer overflow. What could I add? We can remove this because it's duplicate. We can do CVE instead of POC. Zero 006. Known vulnerabilities. And I'm assuming this is as old as the version. 11 years ago. Latest version 6 years ago. And the box is 12 years old. Fine. Amazing. 2013. Else it could be 11 years old. Vulnerabilities affecting your affected version. Directory traversal attacks. Malicious user could list files in folder, and this is what I want to know how to do. And I've heard that it's possible, and I might even have it in my notes. Might expose vector attack system with remote code execution. Removes files with usernames and password. Yeah, so what we could have done, we could have just sent, we could have go buster it, right? Let's do that. I thought of it and I thought, well, let's try and find some logical way of doing it. But the backup fallback thing is really to just try and brute force find something, right? It's not a brainy way to do it, but it's a way. And then we have to have a list. So if we have a list with a bin in there, I guess we would find that name that I didn't want to see, that I happen to see. Oh, let's do it. So, as I assumed, we're gonna find this executable. Let's run here by accessing this one. And let's open a new tab again. And I'm thinking, should we do GoBuster or Ferrix Buster? GoBuster. And so let's so I know I've used different lists, right? Which list is the best for this kind of thing? I've also got GitHub repo links for suggestions. Yeah, so I noticed it wasn't my normal one, that was a suggested one now. So let's do this one. And let's what's the IP? We've been at it about an hour. Well, I started the box before I did other stuff, right? Before the unboxing, so not really, but still. 157, 116. And let's just see if this... let's remove the S from that. Yeah. Ah, I forgot the part. I think in GoBuster you just port it like this, right? So... yeah, and it found bin in 2 seconds. So then we go to this. So this would have been a quick and easy way. No. Hop. Do you want to go to this URL? So when I right click, do you see options disappearing quickly? It just opened this link. It disappears. I don't know why. So I'm gonna go. Well, let's just go to it. Oh well, that's a total fail. Copy selection. Yeah, that easy. That easy. I should always go buster it, I guess. Right. Oh, that's so easy. But I want to find it. I still want to find like a CVE for it. I want to. I don't just wanna end up on it by mistake, like with GoBuster. It's not like it's not a good tool. I just want to know why it works, right? Because it's not supposed to work really. But I guess as we didn't have to go back in the directory structure, I'm kind of assuming we'll end up on the box. Will we? What's initial access? Deploy the machine initial access. Escalator route. Yeah, so we're supposed to go on there by this way. Yeah. That came from Volnhub. So web. Let's actually do GoBuster here then, because that's what was successful, right? No, let's keep web. Let's do GoBuster first, though, as it gives us hints about what to do on the web. So I'm just gonna... this is just so... It feels so stupid. Feels so stupid. So still just 1/200 here. So let's paste that, showing that it continues. And let's do web and go buster, and we'll do something else here later. So web page. I had it here. No. There. Come on. So I don't think it's useful to show the image, as it is also a full URL there. Not much more. I tried tried some and Googled, but mostly found later than 2013 stuff. And then we did GoBuster, and then the output. So I guess I'll go down to... my phone keeps saying unable to charge. I have to... There. Let's... something like this, and let's do a... Right. I just start Sherix again. Since the crash the other day, I'm rebooting my computer before I start streaming, which is kind of nice to do. I usually do it, but I didn't do it the other day, and then it crashed. So now we're doing it. So trying not to get too big images here. There could also be other stuff. Downloading brainpan.exe. The interesting bit here is why would we even think? Now we have the hint before that we're supposed to use a Windows exe to get a Linux buffer overflow, right? This thing, can I drag it like that? Did it move it? We have Brainpan here. Let's move it to THM. How do I make a directory in this graphical thingy? Do we have to go to the prompt to make a directory? I'm sorry. Let's see if it found anything more, by the way. I don't think it will, but there's probably nothing more in there. Oh my god, how many errors do we have? There it is. So so let's put it in here. Wasn't it in here? No, I put it in THM. Then I tried to make a directory and failed. I'm sorry, I'm not good at the graphical Linux. So Brainpan goes into Brainpan. 1. Now we can close this horrible thing left down and only have nice. So let's R2 Brainpan. And I think that won't work. But we'll have to chmod Brainpan. Well, we could do star. And I think this can open it now. No. No. So how do we do it with the Windows executable? I think also Ghidra can open it. Let's Google. So exploring Brainpan exe. So open Windows executable in R2. Okay. Maybe that's better. I just want the R2 start help here. AV. Okay. Let's try that. D is debug. Right, so we need V write mode. Okay. Maybe just A. Let's try just A, not debug, as it can't run it, right? Yeah, that was it. Because it can't debug something that it can't run. But we can still look at the code. So first, let's see what functions we have. We have main here. It seems very main only. Am I blind? Yeah, well, let's PDF that main. So okay, now I know it's main. Why it's main only? It's a long main. So before I do anything else, we should copy this to the notes too. So I'm a bit sad that we can't get the nice colors into Obsidian. Well, I want to make a tool for that. How could we possibly do it? So if we start script before we do this, we get all the escape codes for the colors. Then we convert that to HTML, right? So it's very nice and shows us the full things here. So welcome to Brainpan. Where's the question for the password? Enter the password. Access denied, access granted. So I can't scroll. Why couldn't I scroll? Yeah, let's start with just copying the whole thing. Though we need to get the password from this. And it wasn't as nice to as showing it as
Axio says.
in clear text
Button.
there.
Translated from Slovenian.
I like how readable it is.
Yeah, exactly. It's very, very nice and readable, and it adds the strings very readable too. It's very, very nice. The bad thing is that I can't put this in my notes. So I really would like to convert it to HTML, right? So look at this now. Now it's just white. Right? We can't make screenshots of this much text and put it in here. Let's actually here's the new command. Let's split it here. So we don't need this bit here, but it's still so long, so it doesn't matter. Let's hop back here. So I'm really thinking we could do this, make this like a nice convert, but it's not the goal right now. But this output is very, very pretty. So if I had a wider screen, we could have it even prettier. Or tinier text, I guess, but I don't want tinier text. So we have, before this, let's just read the full from the PDF here. Here's where main starts. It just tells where it's called from, I think, here. And then we have lots of variables. And none of them have any values, but we can get where they're at here. Then we have the start of the function here. It calls sim main move d word and this long thing, and then we have obviously the access denied and access granted here, right? Here's the enter the password that I was looking for at the end of the string. And let's see. So this is just this. Maybe we should write this down in the notes. Why not, right? So I'm just having both up. So this here, I'm just copy that, and let's this is the question string, right? Well, let's say what's the password, and we could really just, to start with, find it in here, and we can see the address. So let's see if we can find any more of it. There's where we got it from. Here is where it's actually used and moved to EAX. Str length, flags. Now let's see, does it have any more times? Yeah. So there, then it's strlen, then it's here. Send 16. Send socket sharbuff length.
Obsidian plugins
That's when
could
it's
highlight.
sending it to us. Yeah, probably. But I want the R2 colors. I don't want anything special like that. We could use HTML to make it. We can make a converter from R2 if we use script to save the output. We have all the characters in there for the colors, so we convert it to HTML. We could do that. But now let's continue understanding the program. So here it sends. I'm assuming send.
Easy.
Yeah. So I'm assuming the send sends it to us. That's how we get the data. Let's just do the other strings too, right? So that's that one. Then we have access denied. Is this? And I did Control C again. Yeah, I did. So access denied, and then we have this. I did it again. Too much windows. There. Access granted. Let's see if we can actually copy it good now, right? So this is where we want to go, right? That's where we want to go. So let's continue using this combination of searching in the notes. It's kind of nice. So if we continue searching down, we'll go to the start, and we'll have all of these three in here. So now I can use Control C. That's why I mess up, because I do it a bit of each, right? So there we have the actual lines. We can't run the program, but we can see these. Let's just continue what I was searching for, really. So hopping back, this is where it's running strength length. And if we go to the send 16 here, then after the send 16, what is done then? receive 16. So it will receive char buff length. So I'm assuming that this char buff here will be something here. Get reply. Let's check out get reply. So PDF at some dot underscore get reply. So that's a nice short function. Start of the function and the ret, and in between we have it's printing stuff, but that's locally, right? So
Ought.
OT? What? We don't probably have to look at this then. String copy. Strings length. It keeps checking length. So why is there a buffer? Copy D bytes to buffer. So it's just outputting that. Let's hop back here. So the get reply does not send anything, and it doesn't seem to have any conditional stuff, is it? It's doing printf, string copy, string length, printf, str, scmp. There's it. That's where it's comparing. I can also say shitstorm in here. So it says shitstorm in here. So that's one of the things it compares with. So we have to try, right? We have to try. So we're already connected here. Access granted. Not that it did us any good. Though it was nice. That's just the password. I guess we have to actually look more at the program, right? But that was kind of what I was looking for, the password. So let's copy this one too. Whew. So we want a buffer overflow, not just a password. I'm just putting this here. I'm kind of thinking maybe we need this in some way. So we got the access granted. But it keeps checking lengths and stuff, but we know that we could overflow the buffer. The question is, how long is the buffer then, right? Wrong. Let's move this to the end. I keep thinking I'm doing stuff in the end. So strcmp. So it seems like the length. This keeps checking the length, but that is for that's for the printing. I'm sorry, my brain hops to the next step while I'm talking, so that's why I'm like pausing, because I was thinking of maybe this is the function that maybe we'll use the strcmp to buffer overflow, and then this will be the variables, and this will be where we'd hop back. And if we look at the top, the very top, it usually says like an address if there's a set address for it and stuff. So I don't really know how I would do this. I don't know the next step. So if you have any suggestions, you're very welcome. So these addresses here, are they the actual addresses? And what do these number of underscores really mean, right? So we have the str copy too, and if you just look quickly at my buffer overflow notes, I know that like all these are vulnerable, right, for buffer overflow, old functions. Buffer overflow. Let's remember to middle click. So I just split it up on several levels, but I think this is where I have a list of some of the functions. So strcopy is one of the vulnerable ones. So we could focus on that one then. So when it does the copy, it won't check. But also when it reads stuff in the gets, where does it actually get? As it's a network read function, right? We had it up just a second ago. Ooh. So what is the variable name for the variable where it puts the data? Let's hop to it's something called buff here. Send, and then receive, and buff. And I'm assuming it wouldn't use buff in case it wasn't the same name it used here, right? Or is this just a C function definition that's not really related to this at all? But it seems so smart, right? So if we go up to where buff is mentioned, it says EAX, but this is the buffer it's sending, right? just getting to the line again here. EAX, this into EAX, EAX into dword buff. Then it's overriding EAX with this.
Buff would be the second to last thing pushed, right?
Yeah, so the problem is that there's not a lot in between here.
If
So
args are pushed
as
backwards,
I don't
it's been a
know.
long time. Hydra.
Yeah. So I'm just following it along already here. So here we put this into EAX. So far this seems interesting to me. Why would it if this is the information sent, it is put dword buff. So I don't know how calls to functions works in detail. I guess I have to research it. Move dword EAX EXP. What does it do here? And then it's calling the send. So this is when it's sending the question before we get to a reply, right? And it needs flags and stuff too. But let's focus on after the send, right? And it's only this bit. This bit of it is between the send and the receive. In here, and
Telling
after
Basilica
this,
says, sheep viewers on stream boo. Calm. Remove the space.
when
At
message
H24
deleted by
PQS4.
moderator. So my bot is removing the message, but not quick enough. So I know the security live was talking about checking if the message was deleted before reading it. So we'll probably add it to the bot, the streamer. What am I saying? The TTS. So let's see here. Yeah. So let's actually Google, because this is a good opportunity to learn how are arguments passed in Python. It suggests. Well, I guess we could use the syntax passed in ASM. Let's do Windows there, right? The first 4 integer arguments are passed in registers. So this was an ugly page. Maybe it's prettier if we note. Nah, it wasn't. Let's just look at this. Integer values are passed in left to right order. Yeah, I have a better suggestion. Let's ChatGPT it. It's usually good at explaining this kind of thing. So should we send it the whole darn thing or just this interesting bit, right? We don't want it to do it all for us. So we could just send it this and ask it to explain. So where do we have a call get reply here? So there will be another send 16. So where's the other send 16? I was blind. Send 16. I want line numbers now. Alright, we could just check the comments. It says send very clearly here. So 1, 2. So 1, 2, 3.
Axio
here.
says.
ORICFIT 16 is syntax to indicate fast call version. Maybe this is a fast call version.
Okay. What's a fast call version? So I'm thinking that between the send of the message and the next send. So I guess I should go down to the next send.
Takes args passed in registers.
Yeah.
Otherwise it would be stack.
Yeah. So between there's the receive, there's so I'm just copying a bit. I'm gonna remove bits of it. So we're not giving up on this manually. I just want a bit of this was removed to the send first one there. And so why are there two sends? So where's the other send there? So in this bit of code here, please help me figure out what arguments go into the send, no, the receive. And what and how we get its result. So also the computer to translate computer, please, right? The receive function is called with 4 arguments. Socket as, the socket descriptor indicates a socket. Well, we don't need to read more about that. But it comes from var 5b0h and the store is EAX. 5b0h was not one of the one I noted down, right? Yeah. The pointer to the buffer where the received data will be stored. This is what I assumed. Var 3fha. So
I think I'm out of my depth. I'll try to just watch and learn. D.
okay. It sounds like you know what you're talking about. So the input buffer. So we're going to overflow this, but we need to know how much we need to overflow it. We can't test anything. Well, actually, we can. But we'll have to go put it on a Windows machine. So maybe that's what we're doing instead of reading this. But this is interesting. I wanna try it this way first. We'll put it on a Windows machine and run it. Okay. Instruction set of the buffer address in EAX, and it's passed as a second argument. In len, specify the maximum number of bytes to read from the socket here. It is set to 1000. Okay. It controls int flags. It controls how the receive operation behaves. So flags value is utilized as 0. Yeah, so here we can see that there's a maximum number of characters here. And I'm assuming that they have factored in this in their code. The receive function returns the number of bytes actually received on success. And -1 on failure. The result is now explicitly shown in this assembly snippet. But it would typically be stored in EAX or another variable for subsequent use. Yeah, so I'm thinking I'd like to look into it further, but let's check this variable out and let's put it on the Windows VM. So if I just search for this, we can see that this is here, and then we have it here. I'm like, where are we in the code? Because that's the bad thing with search, it just hops, and in assembler it's like, I need to know where I am. There's no line numbers. So maybe we could add line numbers here. I don't know if it has it, Obsidian. And we could just switch editors too. Here's the receive, right? So here is this in EAX. Yeah, this is what I looked at before, and it was like, what does this mean? Maybe I should ask you to do it more detailed. But I'm thinking, let's progress instead of digging into assembler a lot, right? Because I don't think it's stream friendly. And this pops up at 11. Yeah, I shouldn't forget about time. So my desktop is a bit of a mess, is it? So I'm making a temp directory. No, I already had one. Well, it's now temp 2. So, because I'm gonna ugly copy this file, as I can't have my VMs on at the same time because I need a new computer. I actually put this, let's see, where is it? So I just need to fix this thing. No? Wrong thing. Oh, what happened there? I managed to click scene tree that I didn't realize I had on even. Here, cameras. This thing. I started working on that one. I need a new computer, but I need to zero it, so I'll probably have to make a new one manually instead. This is stream elements. I can't control it. I can't change the 0 to 0. So that's why we can't have 2 PMs on at the same time. So let's open that directory. No? File moved. Whatever. I can do graphical stuff sometimes. So, home, THM, and then it is, what's the name? Brainpan. So this exe, I'm just copying it by dragging it. Very Windowsy. So we're gonna have to close this down. So let's make sure we have all the data we want here. So is there any other part of this code that we would want R2 to give us? Because we won't have R2 on the Windows machine. We will have x32 dbg is what we'll have, and Immunity Debugger if we had to. So let's just check these functions here. Is there any other ones we could possibly want? Signals, send. We have send 16. We can all look at these too, of course, if we want to. Receive 16. Yeah, we're not gonna check malloc and free and marmoset, right? And there's really I was a bit confused about the underscore name in the function here. So what was the name of that function? The one we listed. Get reply. Yes, I'm assuming that get reply is actually not anything special. It's not. It's just main in here, right? That's actually because functions that are local to this program, they're called, usually don't have an underscore because these are the library functions, right? Anyway, I think we're done, and we copied all of this out. Let's just confirm that we have it in our notes. So in the notes we have the new bit there. That's a get reply. I don't think that's actually, this is a library function, but it can't be because that's where the password is. I'm very confused. I'm very confused about this. Let's check them again. Are the rest of the underscore ones, do they all look like library functions? And because it's much easier to read in here. So we say cleanup, close socket, htowns listen, signal. We say start with lost error, send. I should just look at the code. I'm saying that's done, right? And then we go. This is just the Go Buster. It didn't find anything else. So this we got access granted from Shitstorm, right? We already put that in the notes. We didn't put our tests. So I guess this full listing with the number of characters and everything we tested there. This is really the netcat. And we had a part of that in our notes. The next one then. So I guess I put the rest of it here. And I'm actually gonna remove the last bit because I did this later. So it was like for this. That's what I did. Then I just tested it with the code later there. So yeah. I'm gonna make a new one. Well, let's actually rename this one. With R2. And then we make a new note, 5. brainpan.exe and x32 dvg, because I'm assuming from what we saw that is 32-bit. And I'm gonna remove exploring because we can't see the text, right? Let's do N here too, so we have the same. I don't care which one it is. So we're gonna close Kali down, meaning we have to start it later. But closing everything down nicely here. And we're gonna start this one instead. So if I start both, stream might crash. I'm gonna go and check with my kid in 2 seconds, because I have to make food for him, because we need to leave for school like at 12:45, and I'll be leaving next week 15 minutes earlier. He's got 15 minutes more school, so he's had school problems. That's why he has school twice a week, 2 hours, and he's had 1 hour 45, and now he has 2 hours. So, and he's starting having actual school in school, not just playing cards and ping pong stuff. As this takes a bit of time starting, I'll go talk to him now. So we got a pretty image. Password. So let's make a new folder for the new machine. THM Brainpan 1. And let's open the little folder I made. Let's drag the file in here. There. So now we have Brainpan here. I moved the window, it's thinking. Will the stream crash from moving a window? I guess it hadn't fully downloaded the file. Yeah, it was still starting. It's still starting. No, I don't want to turn on like defense stuff. No. Because. So let's rewrite some of these scripts. So we kind of probably need all of the fuzzer. I guess exploit 2 will be the last one. First of all, we have a fuzzer. We're gonna open it with idle, as it is Python's integrated. It comes with Python installation, the IDE, and we're gonna open, I guess, yeah, and it's got a dark mode, which is nice. So let's start this run as administrator, just to be sure. Let's open.
Born Again says, "Good morning, pretty woman."
Good morning. Pretty woman, that was the first time I heard. Thank you. So we're gonna go to Brainpan and open that. And there's a tiny running in black on the gray, dark gray here. So seriously, can I find this one this easy today? So we were reading memory. That's why that was up. So here we can see this too. But we don't have the pretty nice comments as we had in R2, right? So R2 has the prettiest stuff. Also, we might not be in the same spot that we were. So if we go to symbols, we can see we're in MSV CRT here, right? So if we hop over here, we should be able to see like the same stuff that we saw in R2. Here we see the shitstorm kind of clearly too, right? So some stuff might be easier to see here because it's all graphical and we can just scroll, right? So there's also obvious that this function is in this executable, you know? It's not a library function. Because then it wouldn't have been in the Brainpan here. So, but this is not where the EIP is. This is not where the program is currently running. It's doing some listening or something. The program should be visible here too, the output.
Is that reverse engineering?
Yeah, I guess so. We're going to try and find a buffer overflow vulnerability in this executable, Windows executable. This is a try hack me box, so it's not like advanced stuff. Here's the box. Brainpan 1. Reverse engineer a Windows executable, find a buffer overflow, and exploit it on a Linux machine. So I'm assuming the machine it is running on is a Linux machine, but it is a Windows executable, so don't ask me how. We'll see when we connect to the machine, I guess. But now this is running on our Windows VM here. And initializing WinSocket on, server socket created, bind on port 9999. Waiting for connections. Does this mean that our current localhost here is also showing the web page? Let's see. Oh, well. Localhost. No, because that was 10,000. Yeah. So let's just close this down. We're just waiting for connections here. Just didn't want to have it paused or anything by my click. So let's think. Every time we connect to this program, we need to start it again. We can't send data several times, meaning the fuzzer will need to do a fully new reconnect every time. Let's see here. So the connect needs to be within the while. So let's move it within the loop. And then I don't know, should we put the whole of the thing in there? Yeah. So we want the width in there too. Though we do have an except here, right? We'll have to indent everything. So the while true hops out, this hops in. And then we put the except also indented. So it is all in the loop. The fuzzing crashed, says exit, still works because it will exit if we end up there. So no, because we have the try there. So why am I indenting it? I don't know. I'm not thinking clearly. I was connecting it to the while, to the width. So that's good. So what else do we need to do? This is just a 5,000 non-repeating string. And this function is just to make it possible for us to fuzz still over 5,000 characters, though this is limited. We need to change the port to 9999. And we could have a timeout. It wouldn't matter for this one, I think. Use pattern true. Get string. Yeah. I don't have to redo that bit. That will just get a string. It won't have anything to do with anything else of the program. So I have set it up to do steps. We can decide the step size. And if we want to start at not 0, we can. Then we set this variable called string to this string that we get, which is the number of steps determined by the step, how many steps we've taken, and the step size. We get that number of data from the string, which will start with doing like 100 characters of these. And that is shown there. Yeah, it also prefixes us with a padding. in case we have padding, but we don't, do we? Oh, right, padding is, yeah, it's what we need in case we're over 5,000 characters. If we're not, we're just returning the normal one. I'll probably remove the prefix from that later. Is everything clear? Where were we? So then we print that we're fussing with the string length minus the prefix bytes. In case we need to send something like a part of a command before our string, we don't have that here. Then it just sends this data and the \n, so we actually end the line. Then I did fail to do this. Then we send, we inform that we have sent this, right? This is a string. Then we receive data if we get any receive, and we know that this time we will get a like true or false reply, right? If we got the right code, that's what it's supposed to do. But it won't loop, so we really don't need to receive that unless for our own information. Then the next step is a loop. So I'm thinking maybe we want it to actually pause a second as it's reconnecting, right? So when it is disconnected, we want it to reconnect a slightly bit longer after. So as it's doing a full reconnect every time, every loop. Yeah, so the last program we used this on, it was just within the same, sending replies. So when we connected with Netcat, we wrote something, it answered hello, and what we wrote something more, it answered hello, what we wrote. So this is functioning differently. So let's have the program up so we can see the output. So I want to change the color of this. Right, it will happen next time. I don't think it happens now, does it? So it should next time. Let's run this now and hop over here. And it keeps telling us enter the password. We're not getting the replies actually. So I want to scroll down here. Access denied. That's what I was looking for. So I can't see the full window. So timed out. It crashed here at 700. And before that we got access denied, access denied. And this last one here, 600, it doesn't actually say anything. So this is where it's actually crashing. Then we're sending more data, but we're not getting any response. So actually it crashed already at 600, right? We didn't get a reply. But we have a timeout, so it continues anyway. And we can see the other side. That, yeah. But after I changed the background, as it's not updated for the background, it looks a bit funny. Received connection. I guess that I should put this in the notes, right? So I didn't before. Why didn't I? I don't know. So let's make some more notes. And now we're going to the Windows one. So we go into we start. We open We run the program by opening it in X32 DVD. We run a Python fuzzer script. Program output. And this is what we have in our paste. And then script output. Maybe I should have put this before. Python script output. Yeah, let's just copy that too. So why didn't I do this last time? I don't know. I'm just selecting the output. So here we can see we're sending first 100 bytes, 200 bytes, 300 bytes, 400 bytes, 500, 600. After sending 600 bytes, we don't get the usual access denied reply. And then the program becomes unresponsive. Crashed, in other words. And here we can see also that here's 101. There's the 100 characters plus the \n, and it's get reply s equals. This is its output there. And it doesn't say that it replies, but it gets their new received connection here, right? So the received connection, and then we end just, yeah. Received, no, check is -1. All of this is one section. Check is -1. It is false. Get reply. So why does it show us it twice? Copied 301 bytes to buffer. Copied 301 bytes to buffer. It copies twice. And one is in the function, I'm assuming then. 401, 401, one with check is -1, one is received connection. So, and then for the 501, we get the same. Received new connection until it receives the next connection. This worked, right? But with the 601, the second copy. Yeah, so we're gonna flip the order, because this is the most interesting information, as it tells us more about where in the program it's dying. Here we can also see that for every non-crash we have 2 what does it say? Bytes copied to buffer. So, for the last successful one here, received connection there. And for, so I kind of want to put that extra marked. How we do this? Let's actually do that. And no, I did it in the wrong place. So I don't want to retype this. So the received connection is where I want to break it. So let's move this up. This is why I'm splitting it, because it was not clear to see. It was a bit fuzzy. So here's the new received connection. So this is a last fully functioning one with 500 characters. And then we have the 601 crash. So received connection works on both, then get reply, copy 601 bytes to buffer, and for the last one, the output stops right before it's, what's the next line? Before it gives us the output for the compare. So meaning false, it's we failed, and we also saw this in this output, right? We didn't get any access denied on the 601, and when we sent again, we didn't get a reply. So now we need to know more. Let's actually look and take a screenshot of the program running here. So as you can see, it has paused, exception access violation, and the EIP looks like a very pretty number to me, because this looks like part of the non-repeating string, right? So we want a screenshot of this, really. This, but we can also look at this.
Theodoro says, "Hi, do you prefer this over Windebug?"
I haven't really used Windebug. I don't know what the reason was. Is it not free? Is it like a demo? This is free, a free program. But I have tried also Immunity Debugger, and that is ancient, right? So this is a nice but if you have a link, we can try Windebug too. I know I put it like in my notes of this is an alternative, but I haven't tried it out. There's also other paid options that I don't have then because they're paid. Let's see. So I know that Immunity Debugger uses Mona, and Mona can also be used.
X32DVG is more GUI friendly. I use both.
Okay, so Mona could also be used in WinDBG, I think. So if you wanted to use it, and that is more GUI friendly. Well, I also have Immunity Debugger here, but it's not pretty. So it's also installed in this. But we can install and test. I want to learn all the things, so we can do that. So let's grab a screenshot of this crash here. But I just wanted to check. Do you see all the characters here, right? So here we have this long string. So it's almost at the end. Let's pull this one down again, so we can see the EIP here. I'm thinking, do I want a full screenshot of this? Or should we just grab a tiny one? I don't want to spend all of my resources on storing screenshots of this. Well, let's do a tiny screenshot here, right? So we can get some other registers there. That's a pretty enough screenshot. We get what we're doing. In x32 dbg, we can see.
Why does this crash? The buffer overflow overwrites important data?
Yeah, it overwrites the return address to go to for the next function. So as we put random data, or well, it's not random, it's a non-repeating string there, it's crashing. I'll just paste the image. I'll show you. So, right, actually we have it here. So if we go to when we looked at it at R2, we can see that for every function in assembler here, this is how they start. Push EBP, move ESP EBP. This is what they do. And then at the very end they return. And this return here, what it does, it hops to EIP. And since we have actually, let's hop to my buffer overflow notes. So I'll show you better. This. My notes are public. They're available on GitHub and on my webpage. Visit fixit42.com/notes.
Oh, the buffer is in the stack in this case.
Yeah, it's in the stack. So here we have the information. Let's see. Exactly, the leave does save the old base pointer on the new stack pointer, get the old base pointer, get the old instruction pointer from the stack. It's ret that does that. So ret simply pops EIP from the stack. And that's like always on the stack, this bit. Well, I guess it's not always, maybe then. I don't know. I've never seen anything else. So, yeah. I'm thinking if we were to do it on the heap, how would it be? Let's just continue. This is why, because we're overriding all of this information. The program don't know where to go. This is not a valid address. I think that's what it says. Access violation. You can't access this address and try executing data on there or instructions. That's why it crashes. So if we put a correct address there, which we will, we can control where it goes instead. So let's continue with the box notes. I guess I hop up here again. Yeah. So here we have the crash information there. So EIP. The problem now is I want my Kali machine for this. And it's not started, and if I start it I may crash. Let's try starting Kali, and if it crashes, we have like 30 minutes only left, but I will try to get it started again. So,
What about the call stack? Which function is responsible for overflowing this buffer?
So what function exactly, we don't really know yet. Though I tried before to just go back one step. See where this is the next instruction to execute. What was the last instruction, right? So if we go to the advanced here, there's actually a oh my god, it hopped off. Undo last instruction, right? So I want to do this. And history record is empty. Yeah, so it can't. So we don't know what it was before. We don't know exactly, as we weren't stepping through the program. We don't know exactly where it was. But we can think and imagine where it was, right? From, we both have the code and we have this. But I want to see now, I want to run a program. I know that Mona can do this, though. Let's learn something new. I'm sure we can do this in X32DBG. Actually, we have ChatGPT up. Let's see. Running X32DBG. How would I evaluate the EIP value of my non-repeating string in my... I'm like talking and I don't type at the same time. So I'm like, where were I? In my Python script. The string is from Kelly. Let's just say that from Metasploit. But I know Mona uses the same one. I think that's enough. So, allow the application to crash. Yeah, so once application crashes and you inspect the ESP, it should display part of the non-repeating string. This is the number we have. So, it would be very funny if it... But you can see it's the same pattern. No! No! The purpose here is to only use X32 DBG, possibly with plugins. So the crash. Yeah, we know that. Mona. It doesn't know what it's talking about. Mona can't be used to this.
You can't find the preview's EIP in this case.
So I did install Metasploit for Windows on this machine, and it doesn't start at all. So it was useless, and I didn't want to put time in that, and I really don't want to run the debugger too, right? So, can Mona be run? And it's a Python script, right? So it's not like a complicated thing. It's possible. I've just never seen anything about it.
Axio says,
Is old IP in the stack after popped?
Yeah. So the problem is that this pattern we have, which is 3, 5, 7, 2, 4, 1, 3, 4, that I want to put into. Usually, I would put it into Kali and just
Theodoro
see
says,
the.
it's not.
So the. Yeah, well, we overwrote it before it was gotten, before it was popped, right? So it was on the stack, it was popped from the stack, and it is bad data because we put bad data there. So yeah, it is, kinda is. Though we overwrote the old one. So let's see if it answered. No Mona. Yeah, exactly. So why does it keep telling me to run Mona? I think we'll have to start Kali or Immunity Debugger. So we're going to take
The
a
only
chance.
way you know is to look at the stack for the previous function called.
So we already have all the data we need. We just need a program that can calculate this. I think we can do that with Pwn Tools, but I don't know how yet. I need to learn that. Maybe we should. And we'll have to install that on the Windows machine. So let's just give it a hint. Can't Pwn Tools do this? I know it's a different string though. It uses a different string, I think. It's a different pattern. Generating and calculating offsets. Yeah. So it didn't suggest it. You have to hint for it to understand things, and it's not the same. So yeah, so let's do this. This is a better solution than starting Kali when it might crash the stream, right? And I think we have just the time because I need to start waking my other kid up at 12:15, and then I'm leaving at 12:45. So we just have enough time to learn a bit about Pwn. First, how on earth do I pip install stuff in Windows? I'm assuming we can just open a command prompt. And maybe we need to be admin. It seems to be working. We'll see at the end if it really finishes. I'll just go check on my kid. Yeah, he'd eaten the food. I thought he'd do that himself. New release of Pip, we're not gonna care about that. So, we should be able to use this in our scripts now and make them much better. Because I'm currently using this, right? And now we can just replace this. So, let's make a new line for import. From Pwn import cyclic. Let's actually look what it says for the second one, because cyclic find, yeah. So cyclic and cyclic find. I've never seen these names before, but cyclic, comma, cyclic find. There. Oh, I typed without looking, and then there's nothing. I typed that. No, I don't want to type it again, so I copied. So, instead of this, we're gonna get... That's a bad comment character. Pattern equals... Isn't this much nicer? I'm just scrolling up. Where's the code? Where's the code? Cyclic. I knew it was cyclic, of course, right? Cyclic, and then we do 5,000 because that's what we had before. And we don't want to print the pattern, they're just printing it to show it off here. Then we have the cyclic find. Cyclic find. Very, very nice. So we're gonna have to crash it again because it's not the same data as this. So we used other data, it won't be able to find the value of EIP. But this is a nice modern program, so we just click restart. And now it's nice and pretty and purple. And we can run our script again. So we're just gonna close old output. We're gonna save the script. And this is the only change we need to do for this part of it, right? We're not really needing cyclic find in here though, I guess. We'll have to make a new script. That's very, very simple. And I'm actually copying the code for that. And while we're running this, we're gonna make a new file and paste the code because this actually looks good. And here we're gonna put our value, and this will have crashed. We have a new value here. So I'm thinking notes, right? So our notes is now not anymore up to date. I didn't put the script in here, which I thought I'm gonna do this, right? So now we have a new updated script that is 5,000 characters shorter almost. Isn't that great, right? So our script file is amazingly this much. I mean, do you understand? This is 5,000 characters. I'm not gonna go through it all, but it's like long. So bye line. And then we just copy, and we also save the new one. I'm just putting it back in the notes here. So instead of having a line wrapping around a million times here, we just have a cyclic. And it worked and it ran, so you can say bye to the old stuff. Also meaning we can use this cyclic to get the data, and we don't really need this at all anymore. So I can rewrite my whole script. So time limits. Should I do it now? Let's get the information first, and I'll rewrite this. This is kind of quick. So total size, use pattern, yeah, else. So this is a bit that we need to change really. So return prefix pattern. Yeah, this if is like so not necessary. We don't even need the padding bit. We just need this. And all of this is just old stuff that was useful. And if we were ever not to need it, well, okay, I'm gonna undo again, because do you know what? Nah, I'm changing my mind. Right, this one can't undo. It's doing this instead. So we're gonna move this bit there, there, and there. So total size, if not use pattern. So we have a boolean here saying that we can use the pattern or not. And otherwise it will just D it all. So it's nice if we like, where on earth is the data? I can't find the data. Am I blind? Didn't work? Then we can just put a lot of D's in there and we can just see it easily. That's why we have this. Yeah. So I think this should work fine. So let's just quickly, let's just copy this. Right, I was gonna screenshot it too. Let's make the screenshot. New screenshot with a new one that we need. So I'm just quickly deleting this image because saving data, right? Especially on my web server, because it'll be a mess otherwise. Then we're gonna make a new screenshot. I'm just copying the same bit of there and we're gonna paste it here. So and then we have 666166167 there. And then we're gonna run our new script with this data. So I could of course have copied the value here too, which I was about to do. That has crashed, this, of course. And the untitled will need this before we save it. And we're gonna save it as so cyclic find, I guess. Let's add EAP so it doesn't say get messed up with stuff having the same name. Sometimes Python get well, not only Python, right? I get like a bit iffy about that. -1. So that's a fail. Opponent part, cyclic find, EAP value, offset, cyclic find, EAP value, and I deleted the old image and everything. Print offset. So by the way, this is so not necessary. Why make a variable for that? So and also put the EAP value here. This is really just one line. So, and it will still get the -1 because it can't find this value. So I did delete the image, but I guess I will have to undo the whole darn thing. Except for this port. We added the one sleep. This is where we started adding the new thing. So I'm gonna crash it again, and I'm gonna hop to Cali, and we'll see if I have time to do this. Yeah, I will, because I'll just have to go wake my kid the first time at 12:15. So not functioning yet, possibly, right? Let's do this way. I shouldn't have deleted the image before I knew it worked, right? So I could see the crash there. Using pwn, testing pwn, Failed. Filed. Failed. So,
The buffer values are different each time?
No, they're the same if you use the same script. So, the screenshot we took before that I deleted, it would have been the same as this. Whatever, let's get a new screenshot. I deleted it before I have never used the Pwn tools. So I shouldn't have just done that. Just gonna paste the image, just gonna copy the value, and then so if we run this again, it will be the same. So I'm sorry for messing around. Could it be possible to
set conditional breakpoints for when value in ESP is 35,724,134, for example?
No, you have to set a breakpoint on a line in the code. So we could set a breakpoint here by just clicking any of these, and unset it by clicking again. But we don't know where in the code we would want to stop it. But we don't want to break it right now either. We want it to crash so we can see this number. Yeah. So we're gonna go up and start Kelly, right? So this is a possible crash for the stream. We'll see. Let's just check my Firefox first. Quite a few tabs. I'm just closing Firefox before I do this. So saving a bit of memory there. Nothing else really we can close. It's all stream related. But Firefox can take some memory there. But we don't really need to use right now. I also have a tiny Kali, I think. No, it's not in here. So I have a minimum Kali installation that we could use. But it might not even have Metasploit, I don't know. So no crash yet. I think it's when I start the Windows one after that it's more likely. So we don't need to start the VPN or anything, we just need a terminal. And yeah, we don't want that. I didn't close it. I don't know, I don't want it to restart. So, to hop to my buffer overflow notes here. The fuzzing bit here, I can show you. So this is how the script looks with all the long string in it. Then we check the position. There, to create that pattern, we use the pattern create. And it's Metasploit's Ruby script, right? So this is what we do. Pattern offset, to find the pattern offset. And probably it will pop up if I just type a slash here.
What could this buffer be in real-world production scenario?
This buffer is just a random part of your long string you inputted that was too long for the program couldn't handle it. So you could be anything. Let's say you were typing a input with names, then it's maybe one of the names, a part of a name or something. So it's just random data that you happen to input a too long string. So here we're gonna put the little thing that I forgot to copy. So paste. So now we got an exact match, and as you can see, it is between 500 and 600, which we already knew because we know that 500 was okay and 600 was too much, right? So this we're going to copy to our notes. and like retest, I need to know why it didn't work later. So first of all, I did write the right letters, right? So checking the time kind of carefully now. What position? Also, we got the data from on this, how to write the script from ChatGPT. We could have Googled, right? So that might be the problem, that there might be some, maybe we need to reverse this or something, the order that it didn't know about. So this means we can start trying to exploit this by finding the next step here. If we look in my, after fuzzing, checking the position that we just had up here, right? After checking the position here, this is just my example data. We want to find the bad characters, but we also want to find the return instruction. And then we want to search within the code for example, a jump ESP here, instruction in our program. So we could do that manually by just looking at so we're on the wrong machine now. We need Windows. So that's just one of the instructions in here that will be called that jump ESP. And also I think I have actually the value of it in assembler here. I just added immune to debugger stuff here, which was kind of nice.
Where can I find this exe? I enjoy what you're doing.
Okay, I'll show you. So now I'm gonna start Firefox. If stream crashes, we know why. Out of memory stuff, right? So let's close a few tabs. So now we're safer. This is the machine that we're currently doing, and this is within this you will find this exe. And if you check the start of stream, you will know how I found it. And it's kind of simple, but it's still yeah. If you just run GoBuster on the web server in here, you'll find it easy. I was just trying to find why. What CVE is this? I'll send the link. Oh, where? So.
Thanks.
No problem. So, I'm thinking. Let's actually do a bad charts check. It should be very easily done, as I've already got all the scripts from the last box copied to this directory, and I have a bad cars here. And this is the one I used last time. I don't know why I saved those, but I made this from the other script. So right. I'm thinking, why do I have this? We don't want to have any looping here. Again, use chars, bytes, len 1. This is what we want to use here. This is like an old version. Right, I remember why. Yeah. Yeah, I remember this. So we're gonna make a new one. Else with socket sending bad chars. So now it looks better, right? So what we have, we have the port must be 9999 because that's a current one. Here we should put our Kali machine output. So we want this number here. In here. We can also run this from the Kali machine, but now we're doing it locally. After EIP, EIP pass right times A plus B. So this is a placeholder for the address, for an address, right? So this is what EIP will be replaced with in this scenario, because we're putting 512 A's. Then we're putting 4 B's, which will replace what we had now, this address here. It will be 42, 42, 42, 42 after we run this. And after that position, there we fill in our characters, use chars. So we're going to remove this, because this was from the old one. We were assuming that null /S00 here, this is the value that terminates C strings. So we can assume that it's a bad character. Then this just joins all characters from 00 to FF with this, like removing this from that. It only does it for not in bad chars. And then we convert this to bytes, because bytes is what the send wants. So here's S send, that sends this after EIP. Yeah, I think I deleted too much. No, after EIP is this. I don't know why I did it after EIP. Plus string. String is use chars. Yeah, so we can just remove this line. This is from the old code there, right? So we don't need that anymore. So I had problems. I was debugging. That's why there was so much code. And I keep this comment in constantly because it's kind of good to know. Sending bad chars, send, and we get what chars is sent. And that is all. So let's run that. And it's 18 past. Yeah, so there was another reference to string. I'm just gonna go wake my kid up and then I'll be back. Let's see it. So his time was 21 past. Now I'm like, yeah, now that one is 20 past. Yeah. It's like 2 minutes flying by. Yeah, so we have a bug in the code. So here, I just changed the string. Didn't change the actual what we sent. So now we can run it again, and it works. And it only works though if this is running. So now it's running, and we can see the executable there, and then we're gonna send the bad chars. There. So bling. And we can see the half copy to copy to buffer, and then it crashes, right? So it's crashed again. We can see 42, 42, 42, 42 here. And we can also see that our data here, 1, 2, 3, 4. So what we do now is we just follow in dump. This is dump. We can much easier read the data here. So we're gonna pull this up, and we're gonna read all the numbers here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, hex. And we can follow this. We can look here, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, all up to F8. And over here we have FF. So if we look at all of these here, and there's no nulls or anything, it looks like there's no bad characters so far. It got all the data inputted into memory, and that's what we're checking. So on the last program, what was it, 0A maybe, that actually got, like, it nulled this, or maybe it didn't got in there. I think it didn't get in there even. So should I make a YouTube video on this? What do you think? So this is much easier than like running some odd Mona command. This is logical. You can see it for yourself in memory very clearly. All the characters seem to be good. So now we're going to use some Venom to create a file. So we might have time to finish this one today if I'm mega quick. I have to check on my kid again though. See that he's really getting up. So I didn't think we would have time to do it, but maybe. I don't want to forget to making notes and stuff though. Let's make a new, like, a bad chars one here, right? No, let's just do bad chars here. Bad chars. Checking bad chars. Well, we can't find any, but no. So we're gonna put the Python script in here too, just because I updated it, right? So, my god, I have to click before I tab. So new bad chars Python script. with the debug information I had before removed. So, also the information that we overwrote before.
Terry survived FFA
All
70
the A's
address
are
and
here.
stack after the buffer.
Okay, but that's after our data, so it's something totally different. So the information we wrote all these 41s. These are A's. And then we wrote these 42s, which is the EIP. The next step is to find this instruction, the jump ESP instruction in here. And I think possibly the easiest way to do that is actually to open it in Immunity Debugger, as we have limited time. As we have this limited time now. Well, let's be a bit quick and see if we can finish it. So not gatekeeper. You can see the style of this program, how old it is. So let's just use Mona here. Hopping you back here. Find the return instruction with Mona is the quickest way. We can just use search. Alt E here. But this command is kind of quick. More bad charts here. So we didn't have any this time. So let's just paste this here. And it will give us a nice, very pretty list of... why does it keep being noisy? Found a total of 1 pointer. So it found one jump ESP in our code, and here's the address of it. So this is all we need to know. So we used Mona. We didn't have to mess about with its ugliness. We just Immunity Debugger's ugliness. So we just have a... I'm thinking, should I put this in the notes? Yeah, I should, right? So... a short screenshot of like there. We can get both of them. This is good enough. Both the command and the output in the same screenshot. So we see here what we did, and that's good enough for this box. Yeah. So this address that we got here, funny that it's the same, right? Just pointing it out for us. So we can see that it's in the Brainpan exe, and the data on this is there's no ASLR and so on. The rest of the files would have been not good. So you should use one of these if you make a buffer overflow example. There are other instructions we could use, but still this is the easiest.
Why do we look for JMP ESP?
I will show you now. So let's close this. And here. So you can see we put data here, right? This will be the new stack pointer. This. You see the stack pointer points to this position? That's what it means. So if we look here at ESP, this value here is this. So after the EIP is put into read from, it's popped from the stack. That's the last thing that the return instruction from the previous one does, you know, and it will hop to an address here. And when it starts executing on that address, we put the address here to the return or to the jump ESP instruction. We put it here. the address to the already existing jump ESP in memory, in the code. As we put it here, it will start executing this. And here we can put any code we want, because we inputted this, you know. We tested also that there's no characters that will make it get a big of a hiccup, right? So what we do now is we just... So the only problem here would have been if our address contained null, because we couldn't put null, right? Then we would have to try and find another one. So if the bad characters were in this address, it would have been bad too. So let's just hop back here. And let's put this in text. So 3, we can do 0x to 0x.
Why does Windows let stack to be executable? D?
It doesn't really. It's only when you disable the security features. And it's the same with Linux. We have to make changes to make these work, right? So I have disabled a lot of security features. But they also have to be present in the executables. So these are simple examples for learning. So I'd like to learn more about how we could do this for an actually working thing. So let's restart this so it's ready to be actually hacked now. Let's go to... We can close the cycling fan, the fuzzer, all of these really we could close. And oh my god, that was not on purpose. I wanted to click this because we also have the exploit here. So let's rename this one and open it with idle. There, the other one is 2.7. So we have port 9999. The offset, my god, I shouldn't have closed the other one. Bad chars. So this is what this editor looks like. No, but anyway, it's 2.7. So it wouldn't work to run it. But I do have a paste. So let's put that before I copy anything else. Where's the address? Why don't I have that at the top? Oh, this is the wrong file. It's a wrong file. That's why. I'm like, what's this? So this one we delete, and then we're gonna open and I was like, why do I have this there? So all of these, we looked also at various ones. We can delete those. Copy. So this one. Here. So the new address for the jump ESP function is this. And I don't know why this... I've saved an old one. So let's just start with this one. So we're going to reverse the order of the characters there. So we do F3, which is the last one. Then we do 1, 2, 1, 7, and 3, 1. Right? So now we have this bit reversed. That's like little and big onion difference. Little onion. We need the offset to be changed. That's why I opened up the bad charts, because the EIP position here, I didn't remember it. So there. We're gonna have to make a new we're gonna have to make a new one. I'm not sure this is the last one. But whatever. Yeah. Yeah, this is not the last one. That's annoying. Why isn't this the last one that I made? So seriously, I think I deleted the last one I did. So let's undo that. I think I changed this one to be mine. So let's restore these. So I think I updated this one. Did I? No. Where is it then? I don't care. Let's just fix it instead. I have to go check on my kid. I have to go in 10 minutes, so.
Sir Popstick says, what is this video about? Theodoro says,
So I think...
it's about finding the eat before buffer overflow.
Yeah, so we're almost finished, but I won't have time. I'll have to focus on getting my kid up before we leave in like 10 minutes. So... it's a bit annoying. But I would like to explain everything. But let's just run this and see if it works. With the latest one, it would have worked just to... yeah, I can't take the time. But what we will do, the next step, if you miss my next stream, is we will run MSF Venom, create a reverse TCP shell. We will put my IP here, and we will get Python format. And we will also add bad characters here. So this is not a like modern or updated one.
Sir Popstick says, can someone tell me what EEP stands for? I can look it up.
I'm sorry that I have to stop, but EIP is the pointer in the program that tells the processor what is the next instruction I should run. So if it were this address, for example, it would run the move dword whatever for the next instruction. So as we can control this and set it to what we want, we will be able to control where the program, and we will tell it to run a reverse shell, and so that we can connect and control the computer. And this is the next thing we will do when I start streaming again. Maybe it's 17 today, my time. You can see it's 12:38 now, so I'm going to have to stop straight now, right away, because in 7 minutes I'm driving away with the car, and I have to wake a kid up first. So we're gonna have to find someone to raid.
Cool.
Yeah, so it's
Theodoro
cool.
says,
It's cool stuff.
looking forward to your next stream.
Yeah, thank you. And it'll just be a few hours. I'm going to drive my kid to school. And no one else is streaming on 946 streams. That's a tip otherwise. Let's mute. So, who can we raid? So I raided Keybind yesterday. Should be a study time. I don't know. Let's do Keybind again. There's no one else online, right? I don't have time to...
Sir Popstick says, thank you for your content.
Thank you very much for being here, and thank you for the thank you. So we learn together here. We have put a raid here too. There. So thank you very much for being here. Thank you for learning together with me. Thank you for teaching me stuff too. Because, and also if you ask me something, you know, I get to think and repeat and explain. And that's how you learn, by teaching others, right? How you really learn. So we have this funny, yeah. So, say hi to Kiban from me. I have to really run today, so thank you very much. Bye-bye.
Hey, fix it.